Hello everyone, welcome to Case.Live episode 6, where we will bring you the knowledge and insight and developments of AI so that you can empower your work, your team, and an organization with it. So don't forget to subscribe to our many channels. We have LinkedIn, Facebook, YouTube, and we also have GitHub as well so that you can download the code that we demo and use it to your work, your organization. And today we have three interesting topics. So the first one is how enterprises are dealing with generative AI in 2024. And in the second section, we are providing updates about DALL-E 3, ObjectDrop research from Google. You have two new LLMs, Luna from Pinecone and the DBRX from Databricks. And in the last section, we'll cover building customer chatbot with LlamaIndex, which is a very popular and very hot tool, very useful nowadays. We'll combine it with RAG that we covered in the second previous two episodes before. But now this is going to be a code walkthrough section. So let's get started. So this is about how enterprises are dealing with generative AI developments and technologies. We will base our talk on this article from Andreessen Horowitz, 16 changes to the way enterprises are building and buying generative AI. So they estimated that the budget for implementing and exploring generative AI is going to at least a little bit more than double on average. But in the article, they said that some companies even provided 5x to the budget for AI. So in the year 2023, what actually happens on average is that companies are putting money, about $7 million, to explore generative AI or even AI technology in general to improve their operations, improve their sales, improve their customer support whatsoever. But in this year, 2024, it was estimated to be 2.5x more, putting it at 18 million on average that enterprises are going to put budget for that. Now, what is interesting in that article is that instead of putting money for a one-time exploration on AI projects, some companies are actually putting that budget into a permanent IT spending, meaning that they are seeing AI as their main IT infrastructure. So this is a very interesting development. Companies who are not putting enough budget or who are not exploring or implementing enough AI technologies will be left behind. This is what it means. Also, this plot is number of model providers pushed to use cases. What it means now is that most companies uses more than one providers. So majority of the companies are using 3 or more providers, AI providers, in their use cases. They might be using OpenAI, Google, and Anthropic all together. And there are 3 main reasons to do that. The first one is that they need to tailor to the use cases depending on their model size, the cost, and performance. For example, if you're using a large language model to extract entities from an article, let's say you want to know if an article on the internet is mentions you, your CEO, or your organization in some way, you want that named entity recognition NLP task. So this might be good enough for example, a BERT model. So you don't really need to use GPT-4 for that particular purpose. So yeah, so you are using different models to fit your use case and considering model size, cost, and performance. The second point is that when you use multiple providers, you avoid being in a lock-in situation to a particular provider. Like maybe you are, for example, if you are using OpenAI all along, only just one provider, your business is doing well, and now you have so many tools and the system, the AI system, is getting complicated. And maybe like 2 years down the road, OpenAI just 10x the cost. What is going to happen? You are going to face a very difficult situation. The cost is 10x more, and your system is too complicated now to move to the other provider. So by exploring many providers will actually reduce the chance of being forced to log in to a particular provider. And the last point is by using several providers, it allows you to tap into the advancement of the field. This is true. One of those days you will have like LLM that is very, very safe and harmful and very capable in human language, like Claude 3, for example. You might find that, okay, wow, Cohere model is much better at RAG, where your company have like a substantial RAG applications. So yeah, by using models from different providers, you will gain access to different advancements. So these are the three main points where companies are using models or generative models from different providers. This plot shows the distribution of how different providers are being used. We have 6 main providers here: OpenAI, Google, the Llama team from Meta, Anthropic models, Mistral AI, and Cohere. So from these 3, it seems like OpenAI is taking the majority of the share here. The green means it's in testing, and the blue or navy, maybe, I don't know, it's in production. So yeah, right now most companies are still using OpenAI, and to be honest, I am using OpenAI for my company as well. This is because the tools like libraries, Python libraries, are somehow developed. It's being developed as fast and tethered to OpenAI. Yeah, so I don't know why. Maybe that's because it's a first mover, right? So most libraries are trying to catch up with the OpenAI development. And that makes integration with other models like Google or Llama and Anthropic substantially difficult, but it doesn't mean that you cannot do it. You just need to put more effort into making your code work. But here it is. So in my guess, Google will gain more and more market share. They have a very good engineering team. Their document and cloud computing is good. Llama and Anthropic could catch up. I'm not sure. But they need to provide more infrastructure, because one of the things that Google is very good at is, as I mentioned, the Google Cloud Computing platform. It allows you to use their tools very seamlessly, very good. So if a cloud provider provide its own model, it's likely to be used. That is also mentioned in this article as well. So why do enterprises care about open source? So there's a movement that more companies are trying to experiment and trying to use open source model like Llama and Mistral. One of the things is that they have control that can fine-tune their model to suit their applications. Control and customizability are the top 2 things that most companies are looking for. It's even more than cost. This is true. If you do the model well, you can control it well, and you can customize to your consumers or customers. You can put the high price on it. So cost is not as important as control and customizability. How willing are enterprises to use LLMs for different use cases? So from this work, it seems like enterprises now are more comfortable using generative AI technologies in their internal operation or internal facing applications, rather than external facing that will face consumers. So basically, you will see more on the text summarization enterprise knowledge, customer service, maybe like inside internal customers, marketing copies, software developments. So essentially, they are using the generative AI inside that company so that when the AI answer, they still have some control over the answers. The control means maybe we don't fully trust what the AI is suggesting. We can put human in the loop. So this is an internal thing. You pair AI with human. So AI support human, AI augment human before human takes that insight or LLM answer to do something else. And you will see less about the external facing, like external chatbot, especially when it's very sensitive, like suggesting price or calculating or suggesting like prescriptions, for example. You will see less of that because we all know that the LLM or generative AI, as of today, it's to hallucinate, so it can provide false information, and that is very, very sensitive, or it will put a company in a bad situation when the LLM incorrectly answer to the consumers. Yeah, that's pretty much it. How enterprises are putting effort into generative AI. So the budget, you have companies are providing more budgets, providing moving from a one-time budget to a long-term IT infrastructure. We are seeing companies trying to do more fine-tuning models. So basically, they focus on control and customizability of the model. So yeah, this is for leaders, managers to think about how are your companies dealing with the development of generative AI. How are your company exploring it and investing in it? Provide us a comment. I would like to know. All right, in the next topic, we are going to discuss about updates in the generative AI world. First off, we have DALL-E 3 from OpenAI. It now has Inpainting capability. DALL-E 3 is pretty much a text-to-image generation model. You can access it via a ChatGPT paid subscription plan, or you can also use it via OpenAI API as well. So Inpainting capability is only available in the ChatGPT, the web interface at the moment. So Inpainting means you are fixing some part of an image, an internal part of an image. So when you ask it to generate an image and the DALL-E 3 or the ChatGPT has generated an image to you, you can click the image and you will see this button. This allows you to select which part of an image you want to correct or inpaint. So this is a selection tool. So after you click this button, you will have a new a new menu over here. So this one allows you to change the brush size so that you can quickly paint a big picture, or you can use a small brush to pick up the details. What Inpainting can do, there are three main things that you can do with Inpainting at the moment. So once you have selected the area, you can add some elements or an object into that area. You can ask it to remove whatever it is inside, and you can also ask it to change what it is. So let's actually try it out. So I am in my ChatGPT. I select GPT-4 so that I can access to DALL-E model. What about this? I am going to create an image of a fully visible green cockatoo in a Japanese ukiyo-e art style. And I want a minimalist style background. Let's see what I am going to have. So this is a paid subscription. It's, as usual, $20 per month. You can also have your own GPT, custom GPT. I have covered that before in my very first live episode. Maybe I'll do it again, but this is my custom GPT that helps me create my YouTube subscription. Anyway, so I have my visible green cockatoo in Japanese style, minimal background art too. I think I like it. So now I'm going to try to see if I can add cherry blossom trees over there. This is an adding capability. So let's see. So I have select my tools. This is the brush size. So I want maybe over here. Oh, it's still very big. Okay, maybe here. All right, maybe over there. So add cherry blossom trees. If you are not going to use the Inpainting capability, you can just type into the prompt as well, but it's going to be more difficult to actually identify which location you want to do some add or removal. By having this Inpainting tool, it actually helps a lot. I don't think it kind of works here. Maybe it doesn't understand that area really well. So I'm going to try it again. So I am going to click this image and maybe I will okay, here select a larger piece of land. Okay. Okay, maybe I didn't describe what I needed well. Let's try it again. So this actually happened to me a few times before I present this to you. I tried it myself, and sometimes it works, sometimes it doesn't. I don't know. This is trial and error, I guess. But at least I'm happy with my cockatoo tree. Oh, look at that. So I guess I need to paint a sizable area so that it knows where to put it. Okay, maybe let's try to maybe I want to change the cockatoo to have some accent color. Now the cockatoo is only green. Maybe I want to add some pink to its feather. Let's try. So I have this. Maybe I need to paint. Yeah. So I'm painting my cockatoo in its entirety. Okay, so here it is. It should be fine now. I guess so. Okay. Change the green cockatoo to another. What should I say? Greenish. A cockatoo with green feathers, but with red color accent. Let's see how he's going to do it. All right. Exciting. I'm not sure if I have put the right prompt in there. Human can understand, but I'm not sure if LLM understands what I want. But let's see. So, moment of truth. Though it's doing what I asked it to do. Kind of also change the layout here. Now the cherry blossom appear on the right hand side. Not too bad, I think. Okay. What can I remove? Maybe I want to remove the mountain. Add the background. Remove mountain from the background. What do you think? Is it going to work? Is it going to work? If it won't work, could be because I didn't paint it in a sizable area. could be the reason. So for those of you who are listening or watching, if you have used other tools that has Inpainting capabilities and you think it's better than DALL-E 3, share it with us. Alright, it's actually doing a good job. The mountain is gone. Okay, maybe I want the sun to be yellowish, like a sunset. Make. Should I say make? I don't know, let's try. Make the sun. Change the sun so that it looks like a sun at sunset. I didn't say it outright or explicitly that I want a red sun. I want a sun that looks like sunset. Do you think it will understand? I hope so. For Inpainting, I know that Stable Diffusion or Stability AI tool has that kind of capability. You can also use it for free as well, but you need to install, I think what is called is Automatic 111. Maybe I will do that video tube to cover that one. Okay, good. Look at that. So the sun is now changed to a sunset-like. I think it's good enough for me, so I'm going to save it. Alright guys, what you have seen here is an Inpainting capability of the ChatGPT 4's DALL-E 3 capability inside. What you need to do is ask it to create an image. You click the image that is generated and you click this selection tool so that you can paint the area that you want to edit, and then you type in or in the prompt area what change you need it to do. And there are 3 things that you can do here. You can add objects, you can remove objects from it, and you can change the object. Excuse me. So what we found out is that you need to paint, or you need to select a sizable area for the model to know the context and put what you need in the right position. So for those of you who are going to try this DALL-E 3 Inpainting capability, let us know how well it goes. Maybe you can put it in the comment section, or maybe you can show us how your image looks like. And also don't forget to subscribe to our channel. Alright, move on to the next topic. The next topic is a research paper from Google. It's about a model that will deal with images, right? This one is about object removal, removing an object from a scene, inserting object to a scene, and moving object in a scene. As this example shows, this is the input image, this column, and this is the latest work by Google. So in the first row, you have this scene. Essentially, the task is to remove the bottle from the scene, and you can see this tiny little Lego man over here. And in this paper, the authors provide 4 other techniques in order to compare it with their work. So we have extended mask approach, stable diffusion, Inpainting. So this is Inpainting capability from Stable Diffusion modeled. This is from Stability AI. You have another technique called tight mask, and you have same thing, compare. Why is it the same thing? Anyway, so you have another from Stable Diffusion here. Oh, actually, I think it is Stable Diffusion using extended mask and Stable Diffusion using tight mask. And this is the Google model. This is surprisingly well done for Google. You see the bottle is completely gone, and the little guy here, the little Lego guy, is intact. especially its shadow. The shadow looks as it's supposed to be, right? Also, this is one of the showcase example. I'm not sure if they have picked the best one to show us, and how many bad ones they generate. I don't know, but this from this paper, it looks really good. So this one is a removal task as well. The task is to remove this cottage out of this image. This kind of fails here. It doesn't remove anything. This just removes windows and doors. What is happening here? No one is going to build a cottage. But for Google models, it's completely gone. The cottage is completely gone. And if this is the first time I'm looking at that particular picture, I would not know. You would not know as well, I guess. And this one is also removing a glass of beer from the scene. What is this thing? Why is it there? So basically, it seems like this model from Google, they call it ObjectDrop, is doing really, really well at handling object removal, insertion, and moving. So how are they doing it? Their key approach here is counterfactual dataset. Counterfactual is like, what if this happened? So they actually make this dataset. You have this dataset. So basically they take an image where an object is in the scene, and they take another image where the object is not in the scene. So they remove it. They remove the object. So you have actually, you now have your hands on real world with object and without object images. And this is going to be a source for the AI to be trained upon. So this one is with basketball and without basketball, with a card and without a card. What they are doing next is they are synthesizing an image, a larger dataset. This is this counterfactual dataset is very labor intensive, right? You need to set up a scene with and without objects. This is hard. This is labor intensive. So Google team implement a technique to create a large dataset. So they are synthesizing a larger dataset based on this real world counterfactual dataset, and they are using this larger synthesized dataset to train the model. And that's why that's how it gets to a very good the result. So let's actually take a look into more of its result from this paper. Here we go. So remove, insert, and generate object effects. So you can go into here, objectdrop.github.io, to read more about it. But we are going to go through some examples here, and it's actually mind-blowing. So this one is going to remove a balloon from this image. It doesn't only remove the balloon itself, it actually removes the balloon's shadow or reflection from the water. How does it look like? It looks pretty good. You might be able to see some leftover or artifacts from the balloon's reflection, but all in all, it's actually very impressive. Again, the tiger, now the reflection from the water is gone. I guess this one is removing the helicopter, and the shadow should be gone, right? Look at that. Very impressive. This one, reflection should be gone as well. Oh, and the shadow too. Sleek, right? Okay, this is the approach. Now, this is object insertion, putting object in the scene. This is difficult in a sense that you need to mimic reflections, shadows, and the ambience in that image. This example is going to insert this cactus pods. I'm not sure if cactus or not, maybe, into the scene. Look at that. It's actually pretty good. So think about this. This is a good technology to make advertisement products, product advertisements content, right? You can have a scene and you just need to put your image or product in there and it will look really, really well, right? Look at that. So the shadow comes when they put a car. So this one is putting a swan in a savanna. Okay. I need to say that this is not so well done. Yeah. Well, it looks a little bit fake. At least I can tell. What about this guy? How big will the dog be? It's really big. This is not good, right? This is not well done. But at least it's not bad. So object moving, it's going to move objects in the scene. So shadows, reflections should be adjusted, moved along with the objects. Like this can, for example. This is well done, right? Really well done. Okay, it's going to move this ceramic trophy to, okay, here. Not bad. Look at that. The tree, the part of the tree that was occluded was filled too. So yeah, this is nice. What about this? Trying to move this part of the rocks over here. Cool. And what about this? Is it good? So I think they miss, at least the model missed this part of the wave that is generated by the moving boat there. So yeah, that part of the wave doesn't come with the boat. Didn't come with the boat. But all in all, I think this is good technology, and personally, I am excited to get my hands on this. Maybe it will be incorporated in Google's Imagen 3, hopefully. Alright, and this is it for image-related AI. So in the next two updates, we are going to talk about the large language model, generative model related to languages. So let's start with hallucination. Hallucination can be a huge liability to businesses. That's probably why enterprises, as we mentioned in the first section, do not want to use AI results or replies directly to consumers. So they are not really putting risk so that they will get sued. This is an example where a Canadian airline was held liable for the chatbot giving a passenger bad advice. This is a well-known Canadian airline, by the way. So yeah, so this is an external facing application that backfired because the AI hallucinates. 2 weeks ago, Pinecone, which is a company known for its products, vector databases, it announced that it has the world's first hallucination-free large language model. They call the model Luna. So their technique, in their paper, in their blog article, they trained the model with a technique called information-free training. Pretty much the model was trained without public, semi-public, accidentally public, or questionably public data. So the model is not trained on public dataset. It was only trained by asking itself questions and measuring the resulting answer quality. So only proprietary documents that the model will see, and it will ask itself if it has answered to X question related to the document properly. So this is information-free training, and it results in the world's first hallucination-free LLM, as Pinecone has claimed. So, digging deeper into hallucination and how can we measure it? Researchers have found a correlation between hallucination and factual answering, meaning a hallucination is related to forcing the large language model to answer on some facts, like references from your documents, for example. One of the key metric is called assumed knowledge factor, in which it measures a confidence level that the model think so that it will form factual content to the answer. So that is a correlation between hallucination and this assumed knowledge factor. So most of the large language model out there have high assumed knowledge factor, like GPT 3.5, even Google like Gemma. It has this, it's actually operating in this assumed knowledge factor regime. So it has a high chance. In this paper, it's about 30% chance of hallucination. For Luna, they tweak their training so that the model will be kept at 0 assumed knowledge factor all the time. And that will cause, or at least indirectly cause, the hallucination to go down to 0. They have, as they claim, 0 hallucination rate. It sounds very good, right? But it comes with a price. When they are forcing the model to answer without hallucination, forcing the model to not see any information, public dataset at all, it actually has a poor performance. As they mention in their blog as well, Luna often answers, "I don't know." Is it the right answer? Well, maybe it's better than lying, right? But what they have seen and admitted in that article is that Luna has a relatively poor performance on coding, task completion, and as well as usefulness. I don't think this is relatively poor. As 0 means they can't do it. The model, so pretty much the model cannot do task completion well. The model cannot do coding, and pretty much it's not. It cannot be used as a general purpose large language model. At least this is what Luna is at this current stage, and it's not sure, at least for now, that it can be better. Meaning, in my sense, meaning that I'm not sure if it can be both hallucination-free and can provide general purpose task completion at the same level as even Gemma or GPT 3.5. I'm not sure, and they actually mention it in their paper or article as well. So the verdict for this model is that wait and see, do not use it, do not consider it as much. Just keep an eye on it when they release some new information and so on. The next model that we are covering is the DBRX model from Databricks. So Databricks advertised this as an open source and general purpose large language model, in which it excels in language understanding, benchmarked by the MMLU benchmark. It also excels in programming and math. So here, this is the scores as compared to other open source model like the Llama 2, Mistral, and Grok. So it seems to be doing well in MMLU task. MMLU is actually world knowledge understanding. It has knowledge like physics, biology, philosophy, history, for example. And actually, if you look at this plot, it's actually doing really well compared to other 3 open source model in programming and math. So this is DBRX model from Databricks. It's actually a fine-grained mixture of expert architecture. In total, it has about 132 billion parameters. Now, in general, it's actually surpassing GPT 3.5 in most of the aspects, and it's a rival to Gemini 1.0 Pro at the moment. So how does it do against other open source models. So the highlight, at least from what they have claimed, is that this DBRX model is shining at programming, math, and world knowledge. So what do we have here? We have DBRX Instruct itself being compared to Mistral Instruct, Mistral Base, Llama 2 70 billion chat, Llama 2 70 billion base, and Grok 1. So yeah, in the Open LLM leaderboard, based on these 6 benchmark categories, it wins over the other 5 models. In terms of world knowledge, understanding, wow, it's at almost 74%, better than other models by a few percent. In terms of math, it's actually pretty good, like almost 67% compared to sub 60 or a little bit above 60. So yeah, it's shining in math. And in terms of programming, we measured it with human eval, in which is over here. Programming is substantially better than other open source model. So yeah, this DBRX model is very competent in these areas. But you need to know the size as well, right? This is 132 billion parameters, mixture of expert modeled. Maybe you need, in order to make a full or fair comparison, you need to take a look into the architecture of these models and also the model size as well. What about comparing it to a closed source models like GPT 3.5, GPT 4, Claude 3, Haiku, Sonnet, Opus, Gemini Pro 1 and 1.5, Mistral medium and large? They are not so good compared to these models, except that it seems to win over GPT 3.5 all in most of these aspects. At the same level of Haiku and Sonnet, they are far behind GPT-4, by the way. And yeah, a little bit far behind Gemini 1.5 Pro as well. So DBRX is not the first tier model just yet. It's in the second tier, grouping with like GPT 3.5, Claude 3, and Gemini 1.0 Pro. Mistral Large 2, same tier, same categories. Well, in terms of the context length, it has shown very good context length up to 8,000 tokens. Again, it's beating GPT 3.5 all along, but then the quality of a longer context length, like 16,000 context length and 32,000 context length, dramatically dropped above from that point onward. Still cannot compete with GPT-4, the giant over there, but it has relatively okay similar performance with Mistral instruction. So the context length, DBRX advertised it as well, because the longer context length, the better RAG application, right? And RAG application uses a lot of context length, and from what we see here is that, well, to be honest, most of the models are good, at least good up to 8,000 context length, where the score here is still above 50%. What about the actual test on the RAG application? They evaluated against 2 benchmarks, natural questions and hotpot QA. So here, the performance is as before, behind GPT 3.5, but it actually wins by some margin over Mistral Instruct, Llama, and GPT 3.5 model. So the verdict here is that yes, it's a viable choice for LLM that will, but you need to consider cost and performance as well. At least it can be a good alternative for GPT 3.5 if it's cheaper and faster. All right, this is it for the update section. Now we are moving to the last section that we are going to build customer chatbot based on a tool LlamaIndex. What is LlamaIndex? LlamaIndex is an open source framework for the LLM based application which benefits from context augmentation, which is aka RAG, retrieval augmented generation, in which we have covered it in our previous episodes, episode 4 and episode 5. So feel free to go back and take a look at that. But what it means, what kind of application that RAG allows you to do is something like chat with your data, chat with your document, chat with your knowledge base, like question and answerings from your data, documents, and knowledge base. LlamaIndex, in terms of tools, very competent. In terms of the incoming side, it can integrate or talks to or handle your data, whether it's documents, a database. It allows you to create and handle creating embeddings, converting your document into embeddings and put it into a vector database. It has very well documented and easy to use integration to large language models like OpenAI or even Google. And it has evaluation tools as well, because whatever you build, even whether it's agent or RAG, you need to evaluate that tool before you put it to use, right? So LlamaIndex provide all these functions or tools to use. Now, in terms of application, what you can build with LlamaIndex is Q&A, question answering chatbot, or referencer. You can have it tool to extract information from structured data source or unstructured data source and put it into a structure extraction result. You can build a chatbot. You can build a semantic search tool, search engine. And lastly, but not the least, is you can build an agent in which agent now use tools like RAG tool, search tool, chat tools, and Q&A tool, for example. And all of these are possible with LlamaIndex. What we are going to cover today is this: data loading, embedding using language model, creating database, and building a Q&A chatbot agent. To briefly recover what RAG is, because it's one of the tools that our agent will use today. RAG, this is, RAG stands for retrieval augmented generation. It's a framework to digest your document and putting it somewhere in a search device called indexing or vector embedding database. And when you have a question from a user, you will look up those knowledge inside your database and you retrieve the most relevant piece of information in your document so that you craft the final prompt and ask the large language model to answer to the user queries based on the retrieved relevant data only. So it's a way to reduce hallucination, right? Because right now we don't have hallucination-free language model. I don't believe Pinecone just yet. So RAG is one of those tools to reduce or at least at least provide you with a reason why the model, the large language model, answer to a user in whatever way it is. There are stages in RAG, and we have covered that in the last section as well. But again, this is a summary. So the first thing is you need to load your document, manage it somehow so that you can index it and keep it in a vector embedding. That's it. That's the ingestion part. Now, in the actual part, you get a query and you retrieve, right? During the querying stage, you retrieve the information and you ask the LLM to answer or evaluating the response. So these are the stages that we are going to go through in our walkthrough coding today as well. Now the concept in the loading section for LlamaIndex, there are two main concepts here. The concept is about document. So LlamaIndex provides tools to load your actual documents into the program, right? And this will be kept inside a class called document. And they actually provide tools to parse or to divide, so to analyze document into what they call a node. A node is the atomic level, or according to LlamaIndex documentation, is their first class citizen. So it's the most important part, the most tiny atomic bit that is based for, it is a base for its application or its framework. So basically you have a document, you load it up, and then you use a parser to parse a document into many nodes. A node can be, for example, a node can be one chapter or one heading of your document. So there are many ways to parse a document, but the idea is a document can be split into many nodes. That's it. That's the idea of the loading stage. All right. So before we actually going into Visual Studio Code to go through a walkthrough coding, let's set up a scene. So recall a scene from our last episode. We are going to build a customer contact with Agent and RAG so that this customer chatbot can answer some basic questions to online customers. So we are setting up a coffee shop and we want our chatbot to be able to answer basic information like where the store is, when it's open, what kind of payment it is, what kind of drink menus you have, and for specialty coffee beans, what do you have, how much it is, and how does it taste, what's their taste profile. These are basic information that the chatbot should be able to answer. Why not human? Let's think about it. If you open maybe 10 or 100 or 1,000 branches and you are relying on human to answer these questions, you will need to handle a lot of human agents. Training, dealing with training is one thing. Dealing with complaints, benefits, quitting and hiring is another headache as well. So, and also some human agents are lazy, some are diligent but incorrect, don't have an updated information. So there's so many problems with dealing with human agents, especially when your companies are huge, right? Not to say that humans are no good. Humans are very good, but for basic information, we have better technology to handle that. So, we are not summarizing yet. So let's go to the coding section. All right, let me increase the screen size. So before we go into the coding, so these are the basic information that I want the chatbot to be able to answer. General information like the shop name, what we sell, operating time, location, and payment. I also have menu in CSV format. like coffee drinks. We have small size price and large size price, and also add on. If you want to add ice or change it to oat milk, these are the amount. So these are basic table, drink menu. I also have specialty coffee beans menu put in a table. So we have 4 beans: Geisha, you got Chef, Blue Mountain, and Sumatra Manheling. And each of these coffee beans will have 13 attributes like origin, altitude, flavor profile, acidity, body, aftertaste, processing method, browse level, brewing method, packaging, size, the price, certification, and awards. So these are our coffee beans menu. But for each of the beans, we also have the product fact sheets put inside this folder. For example, this is a Blue Mountain coffee beans. We have origin, attitude, similar to what we had in this one, but this is similar to what we have in this one, but the fact sheet is more detailed, more information there. All right, so just to remind you, we have done this example before in our previous episode, but in that episode we use LangChain and Chroma. We are going to see that by using LlamaIndex today, our code is much shorter and easier to do. Alright, so we have that set up. Now, the first step for RAG is indexing. So let me just clear all the output and restart my kernel. Okay, we are going to use LlamaIndex tool called Simple Directory Leader. You can go to their documentation to take a look at it. It's very handy because you can just provide a base folder. This is my base folder. The docs, I can tell it to recursively go through all the documents or the files inside and exclude hidden. But before I do that, let's see. If I put this to false, you can see that it will try to load this up as well. This also is going to be loaded if you did not say that exclude hidden is true. This is going to make problem later. So here, exclude hidden, put to true. Then you see these are my files, right? I have 3 files over here and I have 4 files inside the product fact sheet. So 7 files in total. Pretty good. Now I have my reader object and I will load from it. I will have 7 documents. These are the documents that I just loaded, right? 7 documents. You can also get to see what's in each of these documents. You can get metadata from each of these documents. So these are the metadata that is attached to each particular document. And when you create a node from that document, these metadata is also copied or transferred to that node as well. Metadata is useful. It can help you to filter, and you can do many other handling, but we are not covering it today. So what other fields or attributes you can access the document? You can have this thing, embedding, metadata, relationship. It is not relationship with anything, the text inside, and so on. So yeah, just to say that there are many other attributes that you can take a look from the document that is just loaded. Now we have the document part. We are constructing the node part, right? That's a tool provided as well inside the node parser module. Today I'm going to just use sentence splitter. I'm loading it up as a node parser where I say the chunk size, just keep it to 200 without overlapping at all. So that's my node parser. Now I am going to now get nodes from document, providing my document over there, and I wanted to show progress as well. My output is going to be the nodes, right? Here it is. It's processed through my 7 documents into nodes now, and you can see that some documents are now processed into many nodes because I have now 12 nodes rather than 7 nodes, right? Right now we have 7 documents, and they went through node parsing, and we end up with 12 nodes. So there are some documents that have more nodes, and you can actually see here. So yeah, these coffee beans are split into 2 menus, 2 parts, 2 nodes actually. Blue Mountain, Geisha. So these are the fact sheets are split into 2 nodes as well. Okay, you know what? The reason why I don't like here is that the menu should be on one page, on one node, so that it understands everything inside the menu. So if I parse it this way, using a chunk size of 200, I have the menu is split into 2. So I'm going to go back to put it to 500, and now the node length is gone. So with 500 chunk size or token size, my files are kept in one node. One document is now one node. So okay, maybe I'm happy with that. So you can see here, you might want some documents to be kept in just one node, depending on your application and your information inside that. And you have the ability to change the chunk size from this sentence splitter here. All right, moving forward, this is my node 1 attribute. Embeddings, not there yet. Metadata includes file path, file name. You see, they copied, this is copied from documents metadata. And so on over here. All right, now we have loaded our document. We have processed it into nodes. Now we are ready to index it. First of all, I just need to load my OpenAI API key. I'll need that. Now, back to LlamaIndex, we are going to use a tool called Vector Store Index, which allow us to easily create an index by putting node or passing a nodes that we have into that vector store index, and we get an index. That's it, guys. You now have an index. You are ready to make RAG system. But before that, we want to keep it into, we have to save it into our storage, right? It's easier than you think. You can just call this. But to show you this is actually, it actually works, I would remove this folder first using this code. Oops, what did I just do? Here, I'm going to run this code. Now that folder is gone. So in order to persist or save my index to a local drive, I just call index storage context persist. Here it is. Now my vector embedding is kept in this. My knowledge base is kept in here. All right, now that's it. So before we build the chatbot, let's go through how the index can be used. The index object that you just created. I'm going to the next Jupyter notebook now. So I am going to retrieve my OpenAPI key here, and this is the location of my index. I'm going to load the index back from this storage location, right? What I can do here is, this other way to do it, you use storage index and load index from storage, from LlamaIndex in such a way like this one. There we go. The storage index from default you put the location. Now you have the context of the storage. Then you use this function to load up your index. If it works, this line of code should be executable chiefly. Here we go. So this is one. This one is that I ask the index to be my query engine, and I ask it to be how much Blue Mountain coffee. It should, maybe someone who is not familiar with Blue Mountain coffee will misspell the Blue Mountain, and let's see how it should be able to retrieve that. So it's actually smart enough to know that, okay, I need to look for Blue Mountain coffee, right? And this is the response. All right, so until now, I have loaded my index, and now I'm going to show you 3 ways to use this index. The first one is using index as just a retriever. Don't do anything, just give me the document that is closest to the query. So from index, you can ask as retriever, give me a retriever this way. And let's say you have an input which is, what does Blue Mountain taste? You give that to the retriever. It's going to get you the documents that are closest or similar to the input query. Now they have 2 nodes. They provide me with 2 nodes. The first one is the node that is about it's really long here. Oops. This one is going to be the node. The first one is the node that is about Blue Mountain coffee bean. So this is the fact sheet node. The second node is, from the look of it, is a coffee bean menu. Here we go. The origin. So this is the coffee bean menu here, right? So this is the second retrieve document. The first retrieve document is this guy, the fact sheet. So yeah, the retriever will retrieve the document that is closest to the input query. Now, you can also use the index as a query engine. The query engine is going to provide an answer on top of retrieving the document. So here we go. We create a query engine using this method, as query engine. And by the way, oops, sorry. Here we go. What is my input? The input is from before. It's asking, what does Blue Mountain taste? So now you run this query, and you will be able to see the answer. The response is, Blue Mountain coffee has a taste profile that includes a rare blend of sweet herbs and so on. So underneath this query, the first step is it's going to retrieve documents, and then it's going to form an answer based on that retrieved document. But the query engine doesn't have a memory, so it's not a good chatbot. For example, with this same engine, I'm asking it, what's my name? It's going to say, I'm sorry, but it doesn't have a context. Who am I? Right? So it doesn't have a memory yet. So a query engine is not a chat engine. But LlamaIndex allows you to create very easily a chatbot. So by using as chat engine, you can have a chatbot. So here it is. I greet it with, hello, I'm Ben. So here, add user message to memory. So now it has a memory element built into this chatbot, and actually is an agent too. So here the agent responds, hello Benz, how can I assist you today? I can ask, what drinks do you have? It's calling a function, so it's calling, this agent is calling a query engine tool with an input list of available coffee. So it create a subquery from my original query, and the subquery is list of available coffee drinks, and put it into that query engine tools, and this is the answer. Now then the agent will answer to me, we have the following coffee drinks available, blah blah blah. Right? Okay, let's test if it actually has memory. What is my name? Here we go. Your name is Spence. So it now has a memory. So this is a chat engine. So in summary, when you have an index, when you already have an index created by LlamaIndex, there are three ways that you can use it as. You can use it as a retriever, just retrieve the nodes or the documents. You can use it as a query engine, provide the answer to this question. And you can use it as a chatbot. It will have a memory so that you can have a conversation with it later. Now we are moving on to the last notebook. We are going to use whatever we built and put an interface, user interface to it as a chatbot. So again, I'm loading my I need to restart my engine. Restart. So as usual, load my API key, and now I have loaded up my index from storage. I am going to create a chat engine using as chat engine. Chat. Oh, forget the message. Hello. Here now the chat engine works. So before I put it into Gradio interface, I have a wrapper function over here. It will wrap my chat history into the format that Gradio wants. So I have ready now. So I am going to reset my chat, and the chat history should be empty. Good. Now I can launch my Gradio. Gradio is done. So let's go to this one. Okay, over here. Here is my chatbot. Let me just increase the size. Hi there. Hello, how can I assist you today? Where are you located? I'm a virtual assistant and don't have a physical location. So I think it thought that I asked where the AI chatbot is. I meant where your shop is. Confusion, don't have a physical shop. This is terrible. What is your shop name? Okay, what is happening here? Did I forget to put in the index? Okay, what do you sell? It should give me, I provide information about shop name, what we sell, address. If you have a specific questions, feel free to ask. What coffee drinks do you sell? we offer a variety of coffee drinks for sale, including different types of coffee drinks and coffee beans. If you have any preferences or specific coffee drinks in mind, feel free to let me know and I can provide more information about them. Okay, you know what? This is surprising. It should be able to handle this better. I think it kind of misses it somehow. And now when I ask it for the location of a shop, kind of misses too. Maybe I need to ask it for the shop address, right? Just remember that we, in our context here, general info, we have a word called address, but I didn't ask it for the address. Anyway, let's continue with the menu here. So it seems like you have seen limitations of very simple RAG technique put behind the agent, right? Okay, let me just ask, show me your coffee drink menu. I'm going to make sure that I put specific words in my query, like coffee drinks here. So with coffee drinks menu, it knows what document it should retrieve: espresso, americano, cappuccino, latte, and mocha. How much is mocha? How much it is? The price of a mocha on the coffee drinks is 4 for small, 5.5 for large. If you have any more questions, is it the right number? All right, 4 and 5.5. That's correct. If I want a large mocha, but with oat milk, how much would it be? The answer should be 5.5 plus 1, so it should be 6.5. The price of a large mocha with oat milk on the coffee drinks menu is 6.5. Surprisingly, it got it correctly. If you recall, in our last episode, I asked when we use LangChain, it gave me the incorrect result. Let's try it again. Maybe this is luck. What about maybe espresso americano, iced americano, small americano with ice? What is it going to do? A price of a small americano with ice is $3. Is it correct? Americano with ice is $3. It's good. This agent can do some math, or at least it knows what the menu, how to compute price for the menu. Okay, let's change topic to the address. What is your shop address? Is it correct? Go back to my fact sheet here. Here, this is my address. Wow, not bad. What about branch 2? Branch 2? So, I think when your query has some specific words that match well with the document, it will be able to retrieve that document and answer to you correctly. How much? How can I pay? This is related to payment in the general information. So cash, credit, Square, and Bitcoin. Cash, credit, Square, and Bitcoin. That's pretty good. That's bang on. So let's ask about specialty coffee beans. What specialty beans do you have? How is it going to do? It should cite 4 beans. Geisha is good. Is correct. Only 1? Seriously? Only geisha is cited. No way. That's bad. List all special coffee beans you sell. I hope it will get me four beans. You see, the problem here is now the CSV file about the specialty coffee beans here. It thinks that the model thinks that this is called this is the name of the coffee beans. So yeah, it's not doing this right. The method with LangChain that we did answer this better. How does Lumotin bean taste like? Okay, what does it do? So the taste should be rare blend of sweet herbs. Wrap. Where's my wrap? What wrap? Over here. Rare blend of sweet herbs, combo blend, chocolate undertone, mild acidity. Has test profile include a blend of sweet herbs, right? Chocolate undertone. So this is good. This is easy, right? Just matching Blue Mountain bean and taste, and find the documents and retrieve it back. A more difficult question would be, let's say I want actually go back to this one. I want a aftertaste, spicy aftertaste. It should give me Sumatra Manheling, right? I want beans with spicy aftertaste. What is it? By the way, I should have mentioned these tables and these fact sheets are generated by OpenAI GPT-4. So don't fully trust that this is the accurate profile or taste. Okay, I want beans with spicy aftertaste. What is it? So Sumatra Manheling coffee bean has spicy aftertaste. If you enjoy coffee with this taste profile, this will be a great choice for you. Awesome, this is correct. So lastly, maybe I'll ask, when is your shop open? Opening hours. Operating hours is Monday to Friday 7 to 8 p.m. and Saturday, Sunday, and national holidays from 9 to 4 p.m. which is correct. So if I ask it, can I go now? Will you be open? It shouldn't be able to answer. That's great. This is good. Based on the operating hours provide, if it's within the shop operating hours, you should be able to visit now. So it asked me to check myself if the opening hours of the shop aligns with the current time that I have. Not bad. Okay. Yes. So this demonstration has shown you a way to build retrieval augmented generation chatbot, more like an agent with retrieval augmented generation as a tool, and you can quickly put it behind gradual UI interface to test. And you can also see that with this simple bot, we still have problems, right? Some answers, some questions, they just don't want to, don't know the answer to understand. For example, I just asked, where are you located? If it knows that it's a coffee shop, it has locations, it should be able to answer to these questions properly. And when I now specify that where is your shop, it doesn't know yet. I needed to put the word address into my query so that it can answer correctly to my query. And it can even fail to answer the shop name. This is bad for PR purposes, like your brand reputation, right? So this demonstration shows you what is possible, but also shows you need to evaluate your AI well. And if you are going to use it for this application, is an external facing application, you need to make sure that it's reliable and it provides the correct information, as like it's going to be your brand related stuff, maybe about pricing and payment as well. It's very critical. You need to test your chatbot well, thoroughly. All right, I think we have come to our last section. So how is it doing? How is it useful? Let me know and share what you have done before as well. So to sum up what we have done today, we have covered 3 sections. The first one, we discussed about how enterprise are now involving or dealing with generative AI. Basically, more enterprise are putting more budget, more exploration into AI technology, and we are seeing more adoption into production level as well. But enterprises are cautious. They are implementing, at least in the production phase, for applications that are internal facing. They are not going to put the AI first to consumer yet. This is based on the limited capability of the AI, as well as a change of giving false information and therefore becoming liable to the business. We also see updates from image-related generative AI like DALL E 3, in which you can now have Inpainting capability. You have advanced from ObjectDrop from Google. 2 new models like Luna and DBRX. DBRX is now a viable alternative for GPT 3.5, open source and capable model. And last but not least, you see a walkthrough coding with LlamaIndex, where we will build a chatbot agent to face with customers, and it will provide basic question answering with a technology called RAG, retrieval augmented generation. And this is it, guys. We are at the end of our Case Done Live today. So thank you very much for sticking with us to the end. Please give us some comments or share your opinions, share your use case, or what do you want to hear from us next. And don't forget to subscribe to our channel, Case Done by AI. We have it on Facebook, LinkedIn, and YouTube. So thank you very much. Don't forget to share us with your friends if it's useful. Have a good day. Bye-bye.